water is important to plants. It keeps plants hydrated and of course keep plants alive. But watering ourselves was quite a load of work to do. And considering our aim wasn't that accurate, resolve in the waste of water. The automatic plant watering system will be the key to solve this problem. So I built one. However, mine wasn't like the others. How does this exactly works? Basically, the Arduino reads the value from the soil moisture sensor and then use that value to compare with the humidity condition from the app. However, this algorithm got flaws because think of the situation. The Arduino pumped the water out and the first few droplets of water land near the moisture sensor and boom! It shuts the pump without even filling the pot. Well, that sucks. So I need to improvise it a bit, which is well, instead of using the value condition of when to open the pump and when to close the pump, we instead use the timer, which came from timing setup of an app, and when the timer reached the limit, we close the pump. You may wonder how I did this, so let's dive deep into an episode of how I built stuff. Welcome to another episode of how I built stuff. At first I plan to use PictoBlocks to program the code thingy to Arduino, and then use a built-in app in PictoBlocks called Codeavour to cooperate with Arduino through Bluetooth. Yeah, it seems simple, right? But the problem is that Codeavour isn't capable of doing what I want to do. So I do what a nice programmer do is I yeet Codeavour into infinity and beyond and replace it with a custom-made app using a mighty app inventor. If Codeavour isn't capable of doing what you want to do, why don't you put all the functions into Arduino and make it a standalone in the first place? And I'll answer, because well, it's gonna consist of several buttons that is both hard to use. Now, one Arduino Nano cannot make all of this magic happen. It needs to consist of something else. Well, let's take a closer look at the circuit, in which contains one Arduino Nano because it's small and cheap, of course. Bluetooth, which we use the module called AC05 by connecting the TX pin of Bluetooth to RX pin and RX pin of Bluetooth TX pin. But the problem is Arduino Nano only got one serial port, which is booked already to upload the program to Arduino itself. And if we want to use Bluetooth, we need to unplug and replug it every time we upload and debug the program, which can be solved with software serial to extension that can turn every single port into TX and RX port, but it isn't available in PictoBlocks right now, so I can't choose it. LCD screen, which consists of 16 columns and 2 rows, which communicate with Arduino using I2C. However, there's no port reserved to connect with the LCD, so instead I use the analog port A4 to connect with SCL and A5 to connect with SDA. Soil moisture sensor, which could connect to every single analog port from A0 to A7, but A4 to A5 was used, so instead I connect the analog port output to A7. Relay module, which it drives the pump by acting like a switch that when Arduino activated, it let high voltage electricity flow out of the pump. In this case, I used an active high relay, which means if we're gonna activate it, we need to set the port of that relay to high. The last port is the water pump, which is the thing that feeds water into plants. Some need the high voltage electricity that Arduino cannot supply. That's why I need to put the relay in the first place. So after I finished all of those programming and tests and went through several prototypes, and I managed to get what I would say is a final product, which you see here, and we assembled all things you've seen in the hardware section, where we got relays and we got Bluetooth and the Arduino Nano right here, and we got a humidity sensor and its module right here and here, and we got an LCD screen up here. Next, let's see it perform in action. So next we're gonna demo test our app. Let me go into our app and then click connect Bluetooth. We'll connect AC05, which is this guy, Bluetooth. We'll pop an error screen for a minute. And you can see the dryness or the humidity live in here. And this is the pump on or off button, so you can turn the pump on or the pump off by whatever reason you would. And this is the pumping control panel where you can set the limits of pumping whenever you like. You want a pump to pump at this roughness, and how long you want to pump, which can be set in the minute timing here, like 2 minutes, 4 minutes, or 1 minute. And you will see the things that I formerly said is 41, but if we set it all to 52 and then we click set, you can see that 41 will change to 52. And I'll demonstrate the pumping by lowering the humidity by pulling the humidity sensor out from the water. So now the draft has risen to 99%, and you'll see the pump is on for 1 minute.